start talking, and I've just turned the record button on so we can make this available to those who aren't here who might want to listen to it. We're going to talk today about the next assignment, unless you have questions about the last one. So I'm going to start with the questions about the last assignment. I see, oh, Denise, you're the other person here. Hi, Denise. So do either of you have any questions about the last assignment before we move forward and talk about logistic regression, which is our next assignment? Hey, Denise, I saw your hi. But questions, are there questions about the last assignment? Okay, no questions from Denise. How about you, Liliana? Okay, well, then let's go ahead and talk about logistic regression. Don't know whether you've had an opportunity yet to look at it, but essentially logistic regression is what I want to call a special case of regression analysis that is done when your dependent variable is not a continuous variable, when you have a dichotomous or sometimes, in more than two category dependent variable, but most of the time logistic regressions are done with, with dichotomies. It has a lot of advantages that in addition to being able to do analyses in which you've got a dichotomous dependent variable, but some of the advantages are that the predictor variables, the independent variables, don't have to be normally distributed to be linear, or any of the other things that were to have equal variances, any of the other things we've worried about in terms of analysis of variance and regression. And you might recall that in every one of those assignments, an early step was to look at the distribution of the scores, whether they were normally distributed, or whether they were linear, or whether their variances were equal. And that's why we did all the preliminary explorations before we did our actual analyses, because if those assumptions were violated, it probably was not a very good idea to continue with that particular statistical approach. Well, the beauty here is you don't have to do any of that. So we don't ask you to go ahead and do histograms or to determine the skew and kurtosis of a distribution, or to do stem and leaf plots or anything of that nature which would precede the actual doing of the statistics. So that's a really big benefit. I think you could probably see that. The independent variables, so the predictor variables, could be any kind of variable. They could be nominal and dichotomous variables. They could be continuous variables. They could be ordinal variables. So it's really a much more flexible approach that we can use when we have a dichotomous dependent variable. So is that a clear, do you understand that? Just want to make sure before I move on that that's pretty clear to you. Okay. Having said that, the actual procedure is going to be a little different, and the output that we get is going to be a little different. I don't know if you have your books with you, but if you do, I think I want to do what I've done the last couple times, which is to tell you what the hints are and how to do this assignment fairly efficiently. First of all, on page 305, there was that checklist that you've had in just about every chapter, and for the most part, if you follow the steps that are laid out here in doing the homework, it's pretty straightforward. And where that doesn't suffice, there's always an example where they walk you through, they give you the variables, they're different variables than the ones that will be in the homework, but they give you the variables and they show you what printout, what output is important for you to be able to interpret, to answer, excuse me, the kinds of questions that are usually asked in the homework. So, for example, on page 296, this is going to look like an awfully familiar table, and that is the tolerance statistics for this form of regression. And it will also tell you in the text that accompanies each of these pieces of output how to do it. So I think if you have been having trouble doing these assignments, that your very best um, guide to doing it is to start out with the checklist on page 305 and to walk yourself through the steps. And if that doesn't look like it's working, then to go back over the chapter where they give you an example and then they walk you through the output that, and you know, how to get the output, first of all, and then they walk you through what that output looks like and how to interpret it. So if you do have your book, I want to suggest that you turn to pages 302, 303, because here is where they're going to help you figure out what information you're going to be getting from your output and how to make sense out of it. So on page 302, and let's back up for a second and say that that this is a study that is being done where, sorry, I'm looking backwards to see what the variables were. They were entered into this equation. Let's see. Okay, so the variables that were examined here are life perspective, and I'm looking at page 298 in case you wanted to follow what I'm doing, the individual's age, the hours worked per week, the years of education, the income, the number of siblings, and the number of hours spent watching TV. And you'll notice here that there's a research question that's been generated. So the question they've generated is, can life perspective be reliably predicted from the knowledge of an individual's age, the hours worked per week, the years of education, the income, number of siblings, and the number of hours spent watching TV per day? So that's the research question. And the dependent variable here is life perspective. And the reason that logistic regression is the appropriate statistical technique to use is life perspective here has been coded as a dichotomous variable, dull or routine or exciting. Oh, dull, routine, or dull or routine or exciting. That's correct. And the independent variables vary. Age is clearly a continuous variable. So are years of education, income, number of siblings. I guess they're all, actually, when I look at these, hours worked per week, hours spent watching TV. So those are all continuous variables as your independent variable. They wouldn't have to be, but they happen to be in this particular situation. So going back now to page 302, this is part of the output that you would get from running a logistic regression. And some of the things that you're looking for, so on page 302, we've got figure 11.12, the step summary. And this step summary is tested by a chi-square for the model. And in this particular example, the chi-square is 33.098, and it is significant, which means that this particular model significantly predicts group membership, whether the person is in the life is dull or life is routine or exciting. So that's the first thing you want to look for is, does the model significantly predict group membership? The second thing you want to look at now on page 303 is the model summary. And excuse me, the very first thing you can see here is the -2 log likelihood. And this is a value where a perfect fit, if you had a model that fit perfectly, where your independent variables perfectly predicted your dependent variable, you would get a 0, which would indicate a perfect fit. So here, the lower the value, the better the fit. And the fit meaning, how well do these variables predict whether somebody sees life as dull or routine or exciting? And so I'm just curious, as you look at this, how good a fit is this model in terms of predicting that particular dependent variable? What do you think, Denise and Liliana, and those of you who are listening later at home? Is this a good fitting model or a poor fitting model? A perfect fit is 0. The fit is 748.595. We're looking at page 303, and it's the very top piece of output. And yes, Liliana, you're correct. It is a very poor fitting model. And that's further supported by the next two columns, both of which are indices to tell you how much of the variance in the dependent variable is accounted for by the model. So remembering, yeah, I see, okay, good. Remembering what we talked about previously around multiple regression, you can see here that both of these indices, the Cox and Snell R-square and the, I can't pronounce, Nagel-Kirky R-square, both of them predict about 4 to 6% of the variance. So, you know, yes, it's a significant model. If you look at that very first chi-square that we looked at on page 302, but looking at this next output table, the fit is pretty poor. It predicts it significantly, but it's not very satisfying, shall we say. Okay, then the next table we have here is the classification table. And if you look here, what it shows you is here they're predicting, I think 0 is life is dull and 1 is life is routine or satisfying. So on the, let's look at step 2 because that's the final model, because this is done in a stepped model as opposed to a forward model. So in step 2, you can see there were 170 people who said life is dull, and the model and there were 170 people who said life is dull, and the model said yes, they look like people who would say life is dull. And there were 107 people who said life is dull, and the model said no, they're going to think life is routine or exciting. And if you look at the next line, there were 121 people that said life is routine or exciting, and the model said no, they're going to say life is dull. And there were 166 people who said life is routine or exciting, and the model said life, that they would put, that they're classified as life is routine or exciting. So that's what the ultimate outcome is. What proportion, what percentage of the individuals in the sample are correctly classified by the model? And if you look at the overall percentage here, 59.6% of people in the study, of participants in the study, are correctly predicted by the model, which is actually not very good. I mean, you want a model that's going to predict upward of 70% or more for it to be an exciting model. So we now have 3 different pieces of information that are kind of telling us the same thing in different ways. We have the -2 log likelihood, which is telling us it's a poor fitting model. We've got the 2 amount of variance R-square kinds of statistics in that same table that are telling us that it actually predicts very little bit of the variance. And we now have that only 59.6% of the cases are accurately predicted. But we have more. You know how the commercial goes. We have more. So now we have, in the next piece of output, we have some things that are familiar to us from a prior regression, or should be, and they're the B weights, which are the unstandardized coefficients, and we have some things that are new, and I'll talk with them in a second. But let me go to the X paren B, which is actually known as the odds ratio. And the odds ratio is another way to see how good a model we have. And a perfect odds ratio would be a ratio of 1. What the odds ratio are is that as the variables, the independent variables, increase by 1, what are the odds of their being able to classify the dependent variable correctly? So if the odds ratio is 1, that means when the the variable increases by 1, the odds of being able to classify them correctly are 1 to 1, which is not that great. So the larger and the farther away from 1 the odds ratios are, the better the fit. And again, here our odds ratios are pretty small. They're pretty close to 1. And you will also see sometimes that the odd ratios are below 1. They might be 0.9 something or other, or 0.8 something or other. And again, those are not very good odd ratios. So we have yet another piece of information about how good our model is. And that's really what a logistic regression is going to show you. And you should be able to answer the questions that in the homework that ask you, well, I'm going to go right down to the end, to the logistic regression at the end. There's some preliminary steps that you'll have to follow to get to that, but you're going to be able to tell us at the end of this thing which variables were entered into the model. And I want to move back for 1 second back to page 303 because I forgot to point to that. If you look at that last table, variables in the equation, there are 2 variables that are in the equation. Their education and their respondent's income. The other variables that were entered in, there were several of them, I don't remember now, five of them I think it was. The others were not significant predictors at all. So the only things that predict satisfaction with one's life, according to this model, is the person's level of education and how much money they make. Interesting. So going back now to the homework, which variables were entered into the model, that means which variables were significant predictors of this model. And in this case, it would be education and income. To what degree does the model fit the data? And that's where you would go through what I just went through with you, that even though the chi-square is significant, there's other information that so that means that the model does significantly predict group membership, but how well it does it is then signified by the other 3 tables that we talked about in terms of the -2 log likelihood, the 2 values of different kinds of R-squares, the classification table, and the odds ratio. And that would be information that you would give us about how good a job the model does in predicting the dependent variable. So the explanation is you provide us with that output and you go through, just like I did with the example, how good fit it is. The constant only model is the model where the constant by itself, you notice on page 303 that the constant is entered into the equation well, let's look at the step 2 thing, and you can see that the odds ratio for the constant by itself is really poor. So in this particular example, it does a better job than the constant only model, and you can present that information to support your conclusion here. If this were the data for the homework. And then the next question, how accurate is the model in predicting job satisfaction? Well, we happen to have life satisfaction here. How accurate is the model? Again, you can use some of the information from these prior tables to answer that question. And then the odds ratio for the variables, again, you can pull that off of the table 1115, page 303, to tell you exactly how the odds ratio comes out and to explain what it means. So that's the part where you're having to explain. Now, how you get there, as I've already told you, is by following the steps, the preliminary steps that are listed on page 305, and it actually walks you through this in the homework by asking you first to formulate a research question. And if you don't know how to do that, go back to page, sorry, I'm thumbing through my book to get the page for you. Sorry about that. Don't need to see this. So back on page 298, there is the research question that is formulated for the example that's given here in the book. So you need to do something similar. You have slightly different variables here, but your first task is to come up with a research question for, for the way in which those data are the independent variables are being used to predict the dependent variable. Then you need to do a preliminary linear regression, and this is where you have to look for outliers, and the Mahalanobis distance thing is very similar to what we did with multiple regression with the last assignment. And again, the steps are under number 1, Roman numeral 1 on the chart on page 305. It's exactly how you go through there. In this case, you'll actually need to delete the outliers that you'll come up with. And you will develop a tolerance collinearity kind of table that will look like the one, I'm again flipping pages, I'm sorry, on page 299. And again, you'll have to make some kind of judgment about whether multicollinearity is a problem for your variables. And then the final step we've actually just gone through before as to what, what you'll need to do. Again, following the table, the chart on page 305. Sorry, I don't know why my computer does this, but you actually conduct the final logistic regression, and then you can answer the questions that are laid out in the rest of the assignment. So, and then make sure of course, you summarize your results. I mean, you should always have a brief summary of your results at the end of all of these analyses. So what kinds of questions do you have now that I've kind of walked you through there? Make sure when you do this that you follow the example I found when I was, what I try to do is I try to do the homeworks before we talk on the phone so I can make sure to find any problem ahead of time and signal it to you. And I found that I had to go back and forth between the between the tabular material on page 305 and the description in the chapter of how to proceed in doing my analyses. So if things aren't clear, I think they're pretty well explained in the chapter, in contrast to the last time's assignment where I found a step that I thought wasn't really very clear at all, and I posted how to fix that. So questions now. Okay. Yeah, I think it's pretty straightforward. Alrighty. The good news is this is the penultimate assignment. So if you've been keeping up, and I think both of you are, just look really quickly. Yeah, I think both of you are up to date, doing well. So you should continue to do well. And I want to point out that next week, it's not quite Thanksgiving week, but well, I guess it sort of is Thanksgiving week, isn't it? Okay, so next week we're not going to have office hours, and that will leave us 2 more weeks. There's another assignment due in a little bit less than a month on factor analysis. We'll have a chance to talk about that again, and then there'll be a week just for any final questions, any revisions that people need to do, and so forth and so on. So there should be some time at the end for any things that have been left undone or unsaid. And if you don't have any further questions, then we can call this an evening, and I'm going to be posting this, so if you want to listen to it again, it'll be there. Okay, everybody. Thank you. Thanks for attending. Talk to you guys later. And if you have problems during the week, email me. Bye-bye.